All right, so good afternoon. In this session, I think this is the fifth session. I'm going to introduce you to KiCAD EDA. We will look at its philosophy, the schematic and PCB editors, and then some other tools that come integrated in it, right? So, in the previous sessions, we've been building the foundation for electronics, and I must say that what we have done so far is enough for me to do this course, right? But that is not all there is, or all there are for the foundation of electronics. And like I said in that session, as we go ahead with our projects, so we'll be learning new things based on the project that we are doing. I would also use it as an opportunity to explain things as and when they come up. Okay. All right. So, is there any questions from the previous sessions?
I don't have any question.
Okay. All right then. Let us get straight into this to the session now. Okay, so basically in this session I'm going to introduce you to KeyCard. How many of you have heard this before or know about KeyCard? Who
Yeah, I've
has
heard about KiCAD.
Okay, so yeah, what did you hear?
Yeah, I know it's a schematic entry software, so you can use to draw schematics and also do PCB layout.
Okay. All right. So basically, in electronics, we call something EDA, which stands for Electronics Design Automation. Okay, and KeyCAD is one of them. They are software suites that we use for doing electronics in these modern days, right? So KeyCAD is not the only thing here in this EDA. KeyCAD is not the only EDA. But then I chose KeyCAD for certain reasons. In fact, there are more powerful EDAs than KeyCAD. We have Altium and even Cadence, Siemens Pad, and all that. These are all highly used in the electronics industry, and the KeyCAD and the rest are also out there. In fact, but then KeyCAD's one major advantage is the fact that it is open source. And over the years, I think I started using KiCad since version 4. It has actually received a lot of improvement. In fact, right now KiCad has become my default EDA. Okay, unless I have something very tight, which actually doesn't even happen often. I don't touch Altium. Okay, Altium is very powerful, but it is also uh, something that is very steep to learn. It's a very powerful tool. It's not easy, and actually, it's not free. The licenses are very expensive. If you're not backed by a company, then chances are that you may have to use a crack, which is not advisable. So KiCad is open source. Now, when we say that something is open source, it means that it is available for free. You don't have to pay anything for using. You don't have to pay anything. In fact, I think yeah, basically that. Okay, and the fact that it is open source doesn't mean it is inferior. In fact, I have worked with a number of these EDAs. In fact, when I started doing electronics and designing PCB, I started with I used to design circuits in CorelDRAW. I don't know who knows CorelDRAW. That's how I started designing circuits. Okay, and then I discovered that there are actually tools that you can use to make life easier. So the first one that I remember using was Altiboard. Altiboard is a product of Multisim. So in one night, I I shone the uh, what do you call it? I showed the Corel Draw because it was quite a lot of work. You have to do so many things by yourself, and it was mundanely boring and all that, right? So, in one night, I discovered Ultiboard because we're using multi-sim suite in school at that time for digital electronics. So, I used Ultiboard to prototype a board that same night. But then I think either I didn't see how to use it, or I don't know what happened. But um, it was like most of the libraries that I needed, most of the components that I needed weren't available. And I'm talking about 2014 thereabouts. So I don't actually know the state of the software right now. But the things I needed, so that's what I'm saying, is either I didn't know how to search for it or they were not there. Okay. So I searched online and realized that, oh, so Proteus 2 has a PCB editor. So that same night, I started learning Proteus, and it was quite interesting. I found the component that I needed, and you could also do simulations with Proteus. Okay, so it was quite interesting until I finally printed out my board, edged it, and I realized that I didn't get my drill holes. Okay, now take note, I'm not saying that Proteus doesn't have the drill holes. I didn't know how to do that. And I was so disappointed because in my diagram the holes were there, so probably I couldn't get a particular setting right. So that's why that happened. So I mean, it was boring. Then I kept searching. So in a night, I actually learned how to use three EDAs. So finally, I found Eagle, and fortunately, I think SparkFun and other fruits use Eagle so much. And way back then, I was using a lot of component from SparkFun, so it was actually easy to get components because they themselves were using it. Okay, so I finally settled on Eagle. I used Eagle for about 2 to 3 years. Yeah, I used Eagle for about 2 to 3 years. It was interesting, but there was one thing that I didn't have then. I think right now there is a solution to that. Uh, I wanted to have a 3D view, but then you have to do a whole lot of things, install SketchUp and some other stuff. Okay, so sometimes I was able to get it done, other times to. Then finally I found KiCAD, and I realized that KiCAD right from the shelf has an integrated PC 3D viewer. Started using KiCAD, and since then, I think since 2017 or 18, I've been using KiCAD for all my developments. Okay, until I got the chance to try Altium, did some two projects with it. Also got the chance to try Cadence. All these are very powerful and interesting tools, right? Like I said, KiCAD over the years has grown so much. It has advanced so much. And most of the projects that I do, KiCAD is just easy and able to do it. Okay, yeah. So for me at the moment, KiCAD is able to do my electronic needs. So KiCAD is great, right? And the fact that it is open source, you make sure you enjoy it, okay? And if you get a chance and get some money, you tip the developers for their good work. Okay, so KiCAD is basically that. It's an electronic design automation suite. Okay, and we are going to learn how to use it. That is what we're going to use to build our system. Okay, the project that we're doing, that's what we're going to use to build. All right, so uh, the first thing we need to do right now is to install it. Okay, so I'm going to take you through the process of installing the KiCAD. I already have it installed, so I wouldn't be downloading, right? But just in case this is your first time, you would know where to find it and how to install it. Okay, all right, so let's get started. Okay, so KiCAD is hosted on kickad.org. Okay, that's the website there you can find it. So that means that we need to bring up our uh, browser. So I am using Chrome. Oh, come on. Bring up the browser. I'm using Chrome. And then, all right. So even if you don't remember kickad.org, you can just search for KiCAD. Okay. And that should take you to KiCAD. So you can see KiCAD EDA, schematic capture and PCB design software. So over here it says KiCAD is a free source software suite. Okay, a free software suite for electronic design automation. EDA, that's where the name comes from. It facilitates the design and simulation of electronic hardware. It features an integrated environment for schematic capture, PCB layout, manufacturing file viewing, ngSpice, simulation, and electro engineering calculations. All right, so these are some basic information. Okay, and you can see that there are other things at the level of KiCAD. So right now, Easy EDA has also become very popular, but I still prefer KiCAD. Okay, so take note. These things are tools. You are not supposed to grow attachment to them. Okay, if in the end you know how to use many of these tools, you just use the one that can do the job quickly, efficiently, and that's all. I mean, I don't understand why people grow an attachment to software. They are tools, okay? If you think KiCAD is not good enough for you and Altium is good, just go and get Altium. If you think KiCAD is good, so just all those comparisons and stuff, I don't think it's necessary, okay? If there are tools that you are using, then use the right tool for the right job. It's as simple as that. All right, so let's go to their website. So that'll be www.kicad.org, and then look at. So,
I think we can't see your screen.
oh, sorry for that. Oh, so all this while you were actually not seeing my screen. All right, then let me just quickly start. So, we're going to install KiCad. That is the first thing you should always do. You need the software on your PC in order to make use of it. All right, so I'll use Chrome, and all right, so we just have to navigate to kickad.org. Okay, now in case you even forget this, just search for KiCAD and you should get to Google should give you a response. So that is it. Okay. All right. So let's visit the site, and the site is so easy to navigate. You can see that the moment you get the main thing, because technically anybody who visit this place is coming for some things, and mostly it's going to be either the software or the documentation, and the engineers of the sites have really done a good job. Okay, these things are easy to find. And please, you are using the software for free. When you get the money, please help donate to them, okay? So that they can also enjoy it. All right. So the next thing that you do is, so you can it's available for Linux, Mac, and Windows, I think. So if you hit on this button, the middle one, and you can download for all this. I think, okay, so there is a Docker version, but chances are that you are using Windows, Mac, or Linux. Okay, so if you're a Windows user, just click on Windows, and it will start installing, downloading. Okay, now like I said, I already have it downloaded, so I'm not gonna do that. So after downloading, of course, you need to install it, and it's always accept, accept, accept. The thing is, even if you don't agree to something, you don't have any choice anyway. So just agree to anything that comes up. Now, in the course of the installation, you would be notified to install FreeCAD. Okay, FreeCAD is also an open source or a free CAD 3D model modeling tool. Okay, so I would advise you install that software because it comes in handy. Okay, unless you have your own preferred 3D modeling tool like Inventor, AutoCAD, SolidWorks, then you can ignore that. But if you don't have it and you are interested in doing CAD, then please, when you get that notification, make sure you install it. Is that okay? All right. So now at this point, I'm going to assume that we have installed our KiCAD and then we have it on our PC. We are ready to launch it. Is that okay? So to launch it, you just go to your start menu and then search for the software. So I already have it here, or you can type KiCAD, however, whatever process helps you. So KiCAD. Now, there are three things you need to consider. In fact, there are four things you need to consider. Okay. Now, KiCAD is a suite of software. Okay, so it has many parts integrated together. The main app it will be just KiCAD, and as at the time of this training, the version there is 7. Now there's 7 point something by then. Yeah, so the version 7 is available. Now there is also the KiCAD command prompts utility, and KiCAD also comes with something called the ES schema, which is also for schematic capture. So if you want to just do schematics, you can just search for ES schema, which is KiCAD schematic editor, and it also has PCB new. Okay, so these are three things that basically form the KiCAD software suite. But then we want to launch them. Now you call this particular PCB editor directly when you want to just do PCB layout without any associated whatever. I don't even know when you would want to use this alone, but chances are that you want to work on a project, and so you need the entire KiCAD to launch. So let us launch KiCAD. Depending on your PC, it will take some time to open. Okay, so when you launch KiCAD, this is the first interface that would be now you would receive. Okay, so this is where everything happened. This is call it the project manager. Is that okay? So you can call it the project manager. So basically you would see three primary interfaces. Okay, the first one, which is your starting point, is what you are seeing here, where you manage your entire project. Okay, now from here you can see that we have other integrated tools. So we have the schematic editor, which I said is an EES schema. Then we have symbol editor. All these are standalone programs that you can use, but through this window you get to have access to all of them. Okay, so if you want to create your own library, you use the symbol editor. If you want to create PCB, you need a PCB editor. If you want to create a PCB footprint, now later I would explain the difference between a footprint and all those kind of stuff. Is that okay? So probably let me just do it right now. So the library schematic editor, that is where we'll be creating our schematic. If you want to do simulations with Spice and generate our BOM, bill of material. BOM stands for bill of material. This is where we do all that. Now schematic is basically your circuit design. Okay, then if you were doing a handwork, we would say that sketching out your circuit. So where your circuit sketch would be done. Okay, where you put the components together. I mean the circuit symbols together to draw out the electrical connectivity for your circuit. Is that okay? So that is what we do with the schematic editor. Now if you come to the symbol editor, the symbol editor is basically used to create circuit symbols. It is used to create schematic, so you can call it circuit symbols. If you remember in the previous session, I talked about circuit symbols. I said that every component has a unique circuit that is used to represent it. Okay, so assuming you want to work with a particular component, and it happens that KiCAD doesn't have it, yeah, you have the chance to create it by yourself. In that case, you say that you are creating a library, and then you can also use it to manage the symbols that you have, or manage what already comes with KiCAD. Okay, so it is not just for sketching out your schematic symbols or circuit symbols. You can also use them to manage your symbol library. Is that okay? Now the next one is the PCB editor. PCB stands for printed circuit board, where we lay out the physical board. Is that okay? So just a moment. All right. So just in case you don't know what a printed circuit board is, um, I don't know if the camera can. So this is an example of a printed circuit board. I think I should do something about my video. What's happening? Just a moment. All right, so in case you haven't seen a PCB before, yes, this is a PCB. Okay, I have a product that I use to train students in programming and electronics. It's called Maybell. Okay, so this is a printed board. This is like the entire circuitry for that product. In fact, so once assembled, this is how it looks like. Okay, yeah, so with this, I train people in how to design, program electronic systems. Okay, by the time I take you through this training, you would be good. You will know how to do systems programming. Okay, so this device, this is the circuit board I built on. Okay, yeah. So this is a PCB, a printed circuit board. Okay, I have more example. I have more examples here. So this is also another product. Okay, yeah. There's also another PCB. Another PCB. I have a lab for creating weird PCB designs. Another one, so you can see that we can have them in different colors. Okay, so depending on your manufacturer, so these things I design them and send the design to China. Mostly I work with JLC PCB in China. Okay, so you have to choose your manufacturer based on their capabilities, okay, and your need. All right, so these are printed circuit boards, and so if you hear me talking about PCB, that's what I'm referring to. All right, so let's continue. All right, so it's within this PCB editor that we do the actual layout. So the PCB is like how the physical product is going to look like. Okay, it's when you are done building it. Okay, so the PCB is where we actually form the physical device. The schematic is just for the electrical connections. Okay, then now the next one is footprint editor. So take note, symbol editor, symbols are for schematic, footprints are for PCBs, right? what we call symbol, what you call circuit symbols, we use them in schematics. But when you come to the PCB, we call those things footprint. Okay, so a footprint is how the component, the physical design of the components, its pin mappings, and all that. Is that okay? Good. So again, the footprint is also used to manage and also design your footprints. Okay, so uh, that whenever you have to design a footprint for a new component you are using, know that you need the footprint editor. Okay. Then we have something called the Gerber or Jeba. I don't know how you would want to pronounce it. I like to call it the Gerber. Okay. So the Gerber viewer, whenever you are done designing your PCB, you would want to ship it to your fab house, right? So personal for me, all my boards have been designing with GLC PCB in China. Okay. Uh, so what they accept is the Gerber file. So take it as the final product output. Okay, so it's a standard for PCB development. So you have to generate your Gerber files, and before you send it, sometimes it is a good practice to inspect your Gerber files. Okay, and this Gerber viewer can help you preview your Gerber files, okay, before you even send them to your PCB fab house or manufacturer. Is that okay? Now, KiCAD also has an integrated image converter, which we use to convert bitmaps into symbols and footprint. Now, we'll be using these things, okay? Almost everything here, we'll be using it at a point in this training, so you will get to appreciate what is happening. Then we also have calculator tools. Okay, so let me bring this calculator tool up. KiCAD has this calculator to integrate a whole lot of tools that are necessary for PCB development. Okay, impedance calculations and a whole lot. Why is this thing taking so long? Oh, okay. So yeah, so this you can see there are some calculator tools. So for instance, this guy here, I think this is for designing voltage regulators. So if you want to design a standard with a 3-terminal voltage regulator and all those kind of stuff, you can put in your parameters, what you want, and then it will give you how you have to do it or something like that. Okay, then we have other tools. In fact, we have a whole lot. In fact, these things are, oh, even if you want to check resistor color codes, right? You have a resistor, you don't know, you need a resistor. Let's say you need a 1 kilo ohm resistor and you don't know the color code. Yes, there is a tool here for you. Yeah, board classes, galvanic corrosion, and so you can check these things out. Okay, they are very, very important. Chances are that most of them, yes, we will need them. We will need most of them in this particular training. Then we also have the drawing sheet editor. The drawing sheet editor is how do I even put it? It's used to create your worksheets. Okay, you can also call it the page layout editor. We basically use it to create your worksheet. Then we have plugin and content manager. KiCAD allows third parties to develop plugins to extend the functionality of the software, right? So for instance, if I click on this plugin, there is this plugin that I use so much, which is a plugin that once I click on it, it packages my design and then make it compatible with GLC PCB's board development requirements. Okay, yes, so it comes in very handy. There are other awesome tools in there, which yeah, so you can see that I have installed or activated a couple of them. Okay, so I want to show you a particular one. Yeah, so if you use PCB Wave, for instance, then you need to use this to install this toolkit. Once you are done with your PCB, click on it and then it will package your PCB for PCB Wave production. Okay, and spark fans, panelizer, and all that. So you just have to read about these things, and if you like them, you install them and use them as required. Okay. Also, let me mention that if you are good with Python programming, KiCAD actually gives you the chance to write scripts, okay, for your development. Okay. All right. So basically, that is that. Now, like every normal software, we have the file view, edit view. Okay. So you can spend some time going through these things and then checking them out. Is that okay? Now, so let us start by creating a very simple or a simple project. So to create a new project, you can go to File. You can see New Project, or you can do New Project from Template. Okay. Then, in case you want to see previous projects that come with KiCAD for demonstration, you can click on the Open Demo Project. If you want to open your own previous program, your own previous project, you can click on the Open Project. Okay. So I'm going to try these two things for you to see, and they are different. So let us start with create new project from template. Now, if you select create new project from template, then it means that you are going to build your project on top of something that is already designed, right? So for instance, if you want to create an Isla two-layer complex, whatever, seriously, I haven't used this thing before. I have no idea what it is. But then, if you want to build a project that uses Arduino Mega, right? Arduino Micro, Arduino Nano, Arduino Pro Mini, Arduino Uno, and there are other microcontrollers here, even KiCAD, Raspberries, HAT. Okay, then you can select if you are going to design for system STM32. You can choose any of this. So let's say that we want to build something with Arduino Uno, right? If I select this, you can see its preview here. So this would come already bootstrapped with the Arduino Uno microcontroller layout and schematic requirements, right? So let's try that and see. All right, so let's save this as let me just save it to my documents, KiCAD projects, just here will do. So let's call it hello Arduino. Hello Arduino. All right, so this means we want to build a project with that, and we want to use that as a base. So building with a template is like you are boilerplating. Okay, those who have a development background, you are starting from somewhere. Okay, so the moment you create a project, you see these things here. Okay, the main thing that we focus on will be the .kicad underscore sch, which is the schematic file. So you can see that it has the same icon as the schematic editor. Okay, then we also have the hello arduino.kicad underscore pcb, which also has the same thing. So this file will contain your schematic, this file will contain your pcb editor. Okay, now to open the file, you can double click here, or you can just click on this. Okay, so far as you have created a project, if you click on it, it will open the currently open project schematic. The same way, if I click on PCB editor, it is going to do the same thing. Okay, so basically that is it. Okay, KiCAD. Well, some people have complained that KiCAD is not easy to use, but then I mean everything is not easy to use in the beginning, right? For me, I think I love KiCAD. Okay, so nothing will change my mind on that. Okay, so once you create your project, the next thing is to open it. Okay, so I'm going to open the schematic. Like I said, you can double click here, or you can just click on this, right? So let's launch KiCAD from here. All right, so as you can see, there are some things already here. Okay, there are some things already here. going to zoom into it. All right, so you can see that we already have some stuff here, and these things you are seeing them because when we started with when we were creating the project, we said it should we bootstrapped, or we created a project from a template, right? So that template is what you are seeing. So this is like the Arduino spin out, Arduino Uno spin out. Is that okay? And if you want to view what is happening at the PC, so this is the schematic editor, okay? So equivalently, a file in the schematic is also created. Like I said, you can also double click on this to open it. So let's open the schematic editor. Sorry, the PCB editor. That one is quite heavy, so it usually takes some time depending on how fast or powerful your PC is. Okay. All right. So just give it some time to open. Okay, don't take too long. Whoa. All right, so loading. Great. All right, so this, if you know, how many of you know of Arduino Uno? You know of Arduino Uno?
Yeah, I do.
Good. I think all of you do. Right, so if you know Arduino Uno, you realize that this is the footprint for Arduino, I mean the board outline, right? The form factor of an Arduino Uno, okay? And then we can actually check it 3D, how it looks in 3D view. Okay, so you can see. Okay, so basically they've done this work of mapping, trying to map the Arduino footprint in case you want to integrate Arduino in the work. Is that okay? So this building from a template actually comes in very handy. Okay, it comes in very handy. All right, so the next thing we're going to do